I'm Stacy, Senior Community Manager from Postgres Professional, and today we will learn how to migrate data from Oracle databases to PostgreSQL. We will provide the materials from this event in our follow-up emails. You'll get access to both video recording and slide presentation. This webinar will last for 60 minutes, and then you will have 30 minutes for questions. You can type your questions in the YouTube chat, and we'll collect them from there. So I'm done with my housekeeping notes, and my colleague Peter Petrov will take the stage.
Thank you, Stacy. Hello to everyone, and welcome to the Stock Application Systems Migration Techniques from Oracle to Postgres. I have been working with Postgres Professional for almost 5 years, and I have participated in many cases. For example, I have written several procedures to transfer data from Oracle to Postgres, and database sizes varied from 1 terabyte to 5 terabytes. And if you're interested, I have started working with Oracle in 2013, and the first version I have ever worked was Oracle 10G Release 2. I have also some experience with Oracle 11 and 12, and a little bit in Oracle 19, since some of our customers have used Oracle 19, and I consult them how to transfer the data from the source database management system to Postgres. And when Postgres is concerned, I have started working with it from 2015, and it may be funny, but my first Postgres version was 8.4. It was the version where Planner has chosen some non-standard and non-optimal query execution plans, and there were lack of features such as window functions, and but the time has passed, and Postgres has become a major and perhaps one of the most sophisticated database management systems in the world, and it's open source, of course. So let's get started and have a quick look into our agenda. I hope you will enjoy it. So the first thing is to determine the source relational database management system features and assessment of migration feasibility. It's vital to find out what the source database management features are used and absent in Postgres, and how to replace them. It may turn out that only a part of the system can be transferred to the new database. The second point here is to estimating costs for the migration process. What will be its duration, what tools will be used, and how much do they cost? And what about hardware? Should it be purchased or upgraded somehow? The third point is data migration itself. What will be the strategy? How to find out change data and transfer it? What about the source code inside the source database? Does the migration procedure fit maximum system downtime, since not every application can be stopped for a long period? And the fourth point is tightly coupled with the previous one, because some data migration tools will be required to solve the problem. Perhaps one of the most challenging steps here is to convert the stored code to Postgres. Keep in mind that the application itself should also be modified, since it could use the source database management system specific syntax and features. Nowadays, almost every application communicates with its external counterparts. Therefore, the specific integration mechanism should be modified and tested as well. The final point is to prepare the system for the business user workloads, or so-called the real-world workload. We should be assured that the system can handle the stress workload and even have some ability to scale. Monitoring tools and backup utilities should also be considered here, as well as the high availability utilities and solutions such as Patroni, for example. So let's start with the first point. And first of all, a schema analysis is required for finding out incompatible data types usage in the source database, such as MDC's SDO geometry for working with various polygons and map objects. It's distributed only as a part of the PostGIS module, and it's not a part of Postgres itself. Specific data types usage, such as blob, row ID, and URI should also be considered. Some of them could be replaced by using the byte E data type. Row ID should be covered by the UUID OSSP module and URI by the PG URI module. However, keep in mind that some extensions are not available in some clouds, and therefore it's required to ask some vendor to include them in the Postgres distribution. The third point is a virtual column usage. It's a field which value is calculated based on the values of other columns. This feature has become available since Postgres version 11. However, I highly recommend to start at least with the 12th version due to partition pruning and optimizer improvements, and I must say significant improvements. The fourth point is external tables for storing the data outside the source database. For some reason, developers choose not to store some data inside the source database objects. The data stored outside in the form of files of various types, such as CSV, XML, and JSON. Nevertheless, the database itself provides some functions, allowing you to treat the data as it was in the new database table. And the destination database management system should also provide these mechanisms. When Postgres is concerned, you could use file FDV if you work with CSV file. However, if you want to work with XML and JSON, perhaps you would like to be familiar with multi-corn module. It provides a lot of foreign data wrapper, because in Postgres, the most advanced technology of accessing some remote data is foreign data wrappers. You can, of course, communicate with your XML and JSON data, and there are some modules such as Oracle FDV, TDS FDV, allowing you to communicate with Oracle and Microsoft SQL Server as well. So, Oracle database supports a large variety of partition mechanisms, such as virtual column partitioning, interval, autolist, and reference partitioning, subpartition template usage, which means that we create some partition, and as a result, the subpartitions are created as well automatically. Alas, Postgres doesn't support all of them, so make sure you adapt the schema according to the destination database rules. So, as a result, the data schema can be migrated as is, or with the following modifications. It's possible to migrate just part of the schema, since some objects may be used in some deprecated code, and therefore should not be transferred. There can also be changes related to the schema normalization and denormalization. For example, some table could be stored as a part of another table in the form of JSON-B object. Also, some additional fields could be added to the existing tables to speed up some queries. You could what else should be considered? For example, replacing column data types with the Postgres compatible counterparts to transfer the data without any errors. As an example, suppose that in Oracle you have some JSON field, however, it's stored inside blob column with a special check condition. However, you can in Postgres you can use JSON-B and not byte E, so you can do it, and the data will be transferred without any errors. Well, at least with the minimum portion of it. Some larger tables could also be divided into smaller sections for reducing maintenance operation time, such as after vacuum, reindexing, and planner statistics gathering. The main reason here is to complete these operations as quickly as possible and not affect users' workload in some negative way. And you could also create some additional data structure for storing some intermediate computation results in various integration scenarios. And you want, for example, you want to save the messages inside them and process the data to build the main application structures. The main point here is that, for example, you just want to tell the source system that you have that you have got the message and it's correct for you, and then you can parse it and fill your main data structures. Okay, previously it has been mentioned that the business application should be changed due to usage of the source database management system specific features, such as old join syntax in queries by using the plus sign, a so-called old Oracle join syntax. This code should be replaced by using the join syntax, since it's supported by the ANSI SQL standard. The second point here is hierarchical queries usage in the application code, such as start with, connect by. Use recursive common table expression instead of this statement, but keep in mind that Oracle can terminate the infinite queries by using the maximum recursion depths. Alas, Postgres doesn't provide such mechanisms, so you should test the termination conditions and make sure that there is no infinite recursive query in the application, because it's very hard to detect them. They don't stop and consume more and more disk space. Okay, what else should be mentioned here? It's the presence of user-defined data types. It's also possible to create custom data types in Postgres and use them in your stored procedures code. Perhaps the application uses some specific models, functions, and procedures for communication with some external systems, like the UTL SMTP and the UTL HTTP packages. For example, some years ago, I used to write some SOAP client for the SOAP web service, and I have implemented SOAP envelope generation, and I also parsed the result and filled the main data structures inside the database. So such logic could be replaced by using models of the application language. For example, in Java programming languages, there are various packages and even frameworks allowing a programmer to implement the same functionality, like in the UTL SMTP and the UTL HTTP packages. And if you want to place these procedures inside your database, you should consider to use PL Python or perhaps PL Perl programming languages, because they can do it, and PL pgSQL is a trusted language. Therefore, this untrusted operation, such communication with some external services, is not supported in PL pgSQL, but available in PL Python and PL Perl, so you can use it. Okay, parallel techniques for speeding up stored procedures calculation, such as DBMS parallel execute, which will be covered a little bit later in the following sections. And also, we should beware of queries in which filtration and join clauses are computed during its execution time. The planner can produce some inaccurate plan, since there is nothing to compare with. You see, before choosing some execution plans and even calculated or computed, the planner gathers some statistics and try to compare it with the filter clauses. Some filter clauses cannot be calculated during the planning time, so there is nothing to compare with, and therefore some plans can be inaccurate. In this case, testing is required to assure that these queries are executed well on the most part of the data set. Perhaps it's not a big problem. Okay, and what about the application itself? In many cases, some third-party libraries are used to generate SQL statements such as Hibernate, NHibernate, Link to SQL, SQL Alchemy, Adonet Entity, and many others. In most cases, they produce queries that use multiple access to the same tables, which may lead to a poor performance, especially when the target objects are large in terms of row count. By default, aggregate and window functions are not used. As far as I know, in Hibernate, for example, you should use special annotations to activate them. Also, by default, there is no common table expression for reducing SQL code duplication. And as it has just been mentioned, many filtering and join conditions are computed during a query execution, which may lead to inaccurate execution plan. In common, if some developer needs to write a complex query, perhaps it's better to use a database dialect, since it's more powerful than object relational mapping library. Okay, when estimating costs for the migration process are concerned, the following things should be assessed. Equipment for developing and testing the migration process and emulating the real-world workload. At least the stage with the full data stored in Postgres is required. There also should be stages for developers, so they can apply the changes and see the results. It's highly recommended to have a separate stage for the stress testing, of course. The second point here is the system conversion and testing, tuning communications with different database management system. The main point here is to prepare some additional data channels, try to emulate the entire situation, measure times, and look for some various logs and see if your integration mechanisms work as expected. The third point is licenses for an alternative database management system and its technical support. Suppose that for some reason a non-free database management system like Postgres Pro Standard and Enterprise have been chosen due to its features. Therefore, license prices should also be considered. Okay, let's have a look to a brief data migration description. First, it's required to create an environment with a copy of the real-world database from the source database management system and a server for Postgres as well. It's essential because in many cases, I have encountered the partial transfer won't show all kinds of mistakes that could occur during the real-world data migration. So it's essential to have a copy. A real copy. The second step is to choose, install, and configure schema and data conversion tools. They can be open source, maybe non-free, or perhaps you'll write them by yourself, who knows. The third step is to choose a migration strategy and decide whether it should be incremental, what will be its run frequency, automatization approaches, etc. The fourth step is to create a schema in Postgres without indexes and constraints. Because it's much faster to load data without them. And after schema creation, the entire structure should be validated. And you can use the data dictionary in Oracle and Postgres site and to compare it. For example, I use Oracle FDV to do that. So I connect to Oracle by using Oracle FDV. I get access to the Oracle data dictionary. Then I can extract my data and then compare it with the data from Postgres and see if I transfer the table structure correctly. Okay, the next step is that to migrate the data to Postgres and check your tool's logs on errors to make sure that the procedure can handle the whole transferring process. Then the data validation should be executed, where row counts and the data itself are compared between the source and the destination database management system to make sure that everything was transferred as expected. After that, the rest of the database schema, such as indexes, foreign, and primary keys, as the constraints and triggers should be transferred, and then a comparison between the source and the destination schemas should be made to verify that process. At least I usually do it by using the system data dictionary, and when the stored procedures are concerned, you can use to some unit tests framework, and we'll talk about that a little bit later. And after that, the rest of the database schema, and then we should gather statistics for the Postgres planner to get more accurate plans. And after that, we should capture changes from the source database management system and transfer them to Postgres if necessary, if you decide that you should get the incremental migration mechanisms to reduce the downtime. So the data conversion tips are presented below. Most of them were discussed at the beginning of this talk. However, I would like to emphasize some of them. You should consider or take into account the possibility of storing various document formats such as XML and JSON, as well as a sequence of nested data structures inside tables columns. For example, JSON in the source database could be stored in the form of blob column with a special check that its content should be a valid JSON object. It's recommended to store it in JSON-B columns in the destination database management system. Of course, it's possible to store a nested table in the form of an array of objects in the form of JSON, but perhaps it would be better to store it as a separate table since better indexes could be created for it and speed up some queries. And when money values are concerned and they are stored in some tables columns, it's highly recommended to store them in some precise data type such as numeric. But if you want to make some math calculation and speed it up, then you may consider choosing an inexact data type such as double and array. Perhaps some large binary data should be stored outside the database and leave only metadata inside it, since the after vacuum can handle them slower than was expected. Moreover, some of our customers have implemented this approach. They store the large binary data outside the database, and that was the decision. Okay, let's talk about data conversion tool, and the first tool that will be considered here is the Oro2PG, which is the open source utility for work with Oracle Database Management System. It provides the following feature: a migration project creation in which for every object type a separate folder will be created for tables, for indexes, for packages, for triggers, for sequences, synonyms, and views, and many others. Oro2PG can scan the source data schema and extract its metadata definition, as well as the data itself. The utility also generates commands to create Postgres-compatible structures. It also can save the data of the source database management system in intermediate files, if necessary, CSV files to be more precise. So the benefits of Oro2PG is the following. You can customize a list of migrated objects by using configuration files and regular expressions. You can also choose what to transfer, not only tables, but the indexes as well. And also we can specify multiple schemas for transferring. And we can also customize the mapping of data types between the source and the destination database management system. We can transfer data directly to Postgres. In some cases, we can write our own queries to let know Oro2PG how to handle this table, the specific table. However, there are some disadvantages of this utility, and honestly, I use it only for the schema creation. When data transferring is concerned, I use another utility, and we will speak about that. But let's consider some disadvantages. The first one, that in some cases it can't correctly convert virtual columns, since in Oracle some statements can be used and they're not supported in Postgres, such as syscontext. So not every combination of syscontext can be handled in Postgres, since in its connection info there are no some information may be absent, and therefore we cannot convert it as is. The utility may fail while working with large binary objects. If it's the case, then some extract transform load utility should be considered for the data conversion. The same situation can happen while converting an object with a large number of rows. Again, consider using some ETL utility. The Oro2PG can convert multiple objects simultaneously. However, each of them will be read by only one thread. If you decide to read a table with multiple threads, then you can process only one. So there is a lack of flexibility in the mechanisms of parallel data reading. And I would like to mention another utility like pgLoader. It can work with MS SQL Server, Postgres, and the MySQL, and provides the following features. It can also scan the source database and extract its schema definition and data. The schema objects can be created directly in Postgres without generating intermediate files, and the utility generates a file containing raw data that encountered an error during processing in the destination database. In this case, the remaining lines are successfully saved. Then users can check the file to see what exactly happened. And if you look for some powerful open source tools, then Pentaho Kettle may be your choice, since it provides the following features. And I use it a lot, and I really like this tool because it allows you to develop and debugging various cases of data extraction, transformation, and loading by using graphical user interface. It's possible to extract the data from multiple databases simultaneously and save them in different forms, such as file, archives, and of course, you can store the data inside another database management system. When you're done with developing, you just transfer the XML file to the server. You install the Pentaho Kettle jar files, since it's written in Java programming language, and then you just run it and see how the data is transferred from the source database to the destination. Also, you could implement your own logic in Java programming language into the extract, transform, load process. You can run some tasks on a schedule, which might be useful for some incremental data conversion. You could design some subtask to avoid repetitive actions, and other task and transformation can use it. And the most important thing is that you can save various metrics during data migration for further analysis as a part of data verification process. So you don't need to go to the Oracle database once more, and it's very good. And so I have already discussed the benefits of Pentaho Kettle. So let's move further. And also, I forget to mention one thing, that you of course can store some error data in log tables to see what exactly happened. And let me show you one example how to design jobs and transformations. This job is designed to transfer some partition table, and as you can see, it consists of 16 partitions. The process begins with the execution of the start component and is carried out by 3 threads. The first one is start to CMIEP1, the second is start to CMIEP2, and the third one is start to CMIEP3. Each transformation is responsible for transferring a separate section. If the data transfer is successful, control is transferred to CMIEP4, CMIEP3 component, CMIEP6, and etc. But if any error occurs, the execution is transferred to abort CMIEP component, and the entire job ends with an error. But what is stored inside this transformation? Let us see. Well, as you can see, it's a simple transformation. There are 2 components: a table input, table output, and PG Postgres bulk loader. The first component is responsible for reading data from the source database management system. It's assigned to a corresponding request and the number of threads for simultaneous reading. The PG CM account entry component is responsible for writing data to the Postgres and uses the copy command for this, which can be significantly reduce the transfer time. And I must say that copy is very fast. It's much more powerful than any bulk loading, such as insert. So I highly recommend to use this component. I like it. It saves me many times. It's also possible to specify a thread count to increase the writing speed, so you can activate more copy sessions, and therefore you can load a lot of millions of rows just in a matter of minutes. Really, it's very powerful tool. So, and let's have a look how to migrate the code. The first step here is to try to convert the code as is by using some conversion tools such as Oracle PG utility, but don't give them large credit since there can be many places that they can't handle. After that, it's required to find some code fragments that can't be translated to pgSQL due to the source database management system specific modules. Perhaps some logic will be moved to the application. Then functional testing should be arranged to detect any logical errors. It's also possible that some code won't perform as fast as expected, and therefore it must be tuned by correcting the code or creating some additional indexes. You see, the main challenge while transferring the code is not the syntax, but its performance. And in many cases, I really need to just rewrite the query since it doesn't fit well. Moreover, in some cases, it doesn't run well even in Oracle. So it definitely should be rewritten. Okay. After that, we should have stress and functional tests as a part of the application. And after that, we should consult our logs and metrics to see if all the scenarios are worked as expected. If not, then we should tune the application based on the result of the functional and stress testing. The available converters for the stored code migration are presented below, as I have just mentioned, Ora to PG. A second project is very interesting. It's Antelair 4. It has its own grammar files for PLSQL and T-SQL code, and not only for this language, they have a lot of grammar files. However, I should warn you that this utility allow you to generate a set of classes. So it takes your code as an input, and as the output, it returns a set of objects for the desired programming language, for C++, for Java, Python, Golang, many others. It's a very large and sophisticated project. And however, this set should be processed by user to produce code in pgSQL programming language, since only you knows how to transfer your code. And the third point is third-party online conversion services such as SQLlines.com, but in complex cases they cannot do the job well. So if you're really interested, I highly recommend you to investigate Antelair 4. Perhaps it will help you. And let us consider some incorrect code conversion we're using Ora to PG. As I have just mentioned, it's old Oracle syntax, so we should use for example, Toad for Oracle to convert an old syntax to a new one. The second case is pretty tricky. It's so-called decode statement. You may ask me, but we have Ora FSE. Won't it be enough? Well, you see, decode statement is working the way as follows. When we find some condition which is true, the rest of decode statement is not executed. But in Ora FSE, decode is a function, and therefore each and every argument should be calculated, and it may not be desirable. And I have some cases where that's not desirable. So decode is not a statement in Ora FCE model; it's a function. So please remember this. And the most trickiest part is the Oracle implicit type conversion is ignored. For example, during a string conversion to a number, Oracle erases leading zeros. In Postgres, it should be done by the application developer. And if you don't know this moment, you eventually got an incorrect result. And it's very hard to detect such kind of errors. And no conversion tools can prevent you from that. Therefore, the functional testing should be provided to see if your code works correctly. And of course, the recursive query syntax is not supported. It means the old query syntax, but you can use the new recursive query syntax and Oracle, and therefore it makes your life a little bit easier when transfer them to Postgres. But please remember about infinite query. In Oracle, Oracle can protect you against that, and Postgres cannot. The reason is uncertain for me, to be honest. I don't know the reason why the community haven't implemented the same thing to Postgres, to be honest. If a query has columns with double quotes, it may not be translated correctly. Sometimes Ora to PG can put column names into lower register. As a result, a query can't be compiled due to the syntax error. The construction, so-called the best, the worst, you can see this statement on the slide. It's not supported. The external model first last AGG is required. This model is really amazing because it allows to erase a lot of join operations. And the one reason I couldn't one thing I can't understand why it's not the part of Postgres contrib module. It's a very small extension, but it's very useful, and it really helps to save the day. Dynamic queries are not always converted properly. It's so-called execute immediate because inside the rows you can see the old Oracle syntax sometimes. And if you ask me about the PLSQL package, Pavel Stehule has implemented the counterpart of the PLSQL, but I should warn you that it doesn't cover all the functionality you need, and Pavel Stehule has mentioned it in the documentation. The code with the usage of the DBMS XML DOM and blob should be rewritten manually, so Oracle PG cannot help you with that. And moreover, some queries, as I have just mentioned, should be rewritten manually to provide the required performance. And the most common cases and their solutions are presented below. And the first one is usage of the advanced queue, DBMS AQ, to encode and decode the messages between various system components. The solution related to queue mechanisms can be implemented on the application side, for example, by using the various technologies such as Apache, Kafka, and ActiveMQ. And the external Postgres module pgQ can be used as well. However, it should be tested in terms of speed. The second point is technologies for building applications based on Oracle, like Apex and FormSpider. To be honest, I have never seen such counterpart for Postgres. So, because it's a very complex field, and I don't think that they will be free. Hierarchical queries with the old syntax usage, we have already discussed it. They can be replaced with the recursive common table expressions, but beware about infinite queries. And usage of the old syntax for table joining. In this case, you can use Toad for Oracle to convert it. This tool is not free, however, it does its job pretty well. And we have already discussed interaction with some external services at the database management system level. You can use PL Python and PL Perl, or to use your application and packages and models to implement this logic. PLSQL collection usage, like associative arrays and nested tables, it can be replaced by HTOR and JSON and an array of objects. The next point is usage of blob XML type JSON data types, as well as various packages for their manipulation. Blob data type could be replaced by byte E, XML type, JSON to JSONB or JSON. And now the topic I have promised you to talk about. It's a called DBMS parallel execute package. Maybe among you are those people who work with Oracle 10 and remember how the things were done until Oracle 11. We construct the query, we divided our data in some chunks or packages, and then for each package, a background job was created by using the DBMS scheduler package. And by the way, the DBMS parallel execute uses the DBMS scheduler under the hood. And after that, we check all its status, and if all the statuses were correct, then we proceed with our computation. So I can say that in Postgres, the situation is the same as was before Oracle 11. So we should use some scheduler module like pgPro scheduler if you are a Postgres Pro customer, or pgcron, pgagent, pgtimetable if you prefer open source, and do this and do the things as was used to do before Oracle 11. So the next point is frameworks for unit testing of the stored code, and it's pgtab and pgproof. In my opinion, it's the only way to make sure that the code is transferred correctly in terms of business logic. So you can write your own test and see if it satisfies the desired result. Autonomous transaction usage is the next point. They're available in Postgres Pro Enterprise distribution, and DB-Link or PG background models could also be used for that. In some cases, global data structures are used at the package level. The PG variables module could be used for storing various data structures during user sessions. This module has been implemented in Postgres Pro Company. It's free of charge, so you can download and use it. What about row-level security? Postgres provides a row-level security mechanisms for the implementation of additional row access rules, and recently we have encountered some bug which leads to memory leaking, but luckily this bug has been corrected, so there is no memory leaking anymore. So, and I would like to emphasize that be wary of queries with filter and join conditions. That can be calculated during a query execution time. You should test your query to see if it's if it works as expected for the most part of your data set. And the last point, it's what are the counterparts for DBMS scheduler package? As I have just said, PG Pro scheduler as a part of Postgres Pro Enterprise. And if you prefer open source, you can use PG Agent, PG Cron, and PG Time table. So I have just discussed how we can work around some limitations. So let's go further. Yes, and there is one thing I would like to mention. It's about PL profiler extension. In some cases, you don't understand which procedures are executing the most. So you should use this extension. It allows you to build a report after the execution, and you will see the function and procedures that have been executed the most time. And then you can consult your source code and to see what's really going wrong. So, and what about interconnection? About interconnection testing between related systems? As I have just mentioned, the main part here is to implement some communication channels, try to transfer the data from external database to Postgres and measure times, and vice versa, and to see if it works as expected, and check the times to see if it works as expected in terms of performance, and if it doesn't, so some optimization should be made. And I have just mentioned various FDV modules such as Oracle FDV, TDS FDV. They are free of charge. You can download and use it. So finally, the system must be prepared for the real-world workload. For that, the following steps should be considered. It's preparation and testing a code and data conversion solution, and acceptable downtime should be taken into account here. Then we should choose and customize a backup and recovery solution, choose the monitoring tools, to think about fault tolerance and disaster recovery, like high availability, and then create a plan for system real-world usage. Let's start with the first point. And the main goals here are downtime reducing and avoiding code reconversion. So the first thing we can do is to capture changes in the schema definition and its data. The second one is detecting unchanged data and its conversion. Perhaps you have append only table, therefore you can transfer the most part of it and save your time. You can use triggers for capture data changes, but the overhead can be significant. So think twice before using this solution. Maybe not, but in the cases I have seen, the overhead was pretty solid. And then data transfer procedure should be tested, and its execution time should be measured as well. And before the final migration, you can suggest to freeze the application code development to make your life a little bit easier, and detect stored code changes by the database system dictionaries, like time changes, time created, and of course use ANSI-compatible syntax for writing new queries on the source database management system. For example, you can use Oracle recursive new query syntax, common table expression, and don't use the old syntax. Okay, and let's talk a little bit for the change data capture solutions. The first solution is to use materialized view log, And this is the main reason the Oracle can refresh your materialized view incrementally, because for each and every table in this materialized view, a separate materialized view log is created, and it stores the changes, and therefore when you say refresh, it uses the Oracle uses its data, and therefore incremental changes and refresh is possible. And the same solution was implemented here. This solution is tailored to the business reporting schemas as well as Oracle Business Suite. Perhaps maybe it's maybe it's not for you, but if you come from Oracle Business Suite, perhaps you should consider it. And there are some cases when this solution has allowed users to transfer the data. The second approach is perhaps the most popular one. It's LogMiner for redo and archive journal analysis. Debezium uses this approach, as well as Informatica. You can click the link below and links below to read in more details how it works. But in short, LogMiner, and we use LogMiner to analyze changes in reader logs and transfer them to the message queue. Some our colleagues have implemented the same approach, and they have reported that there were no additional overheads detected, and the LogMiner overhead is no such significant as in the triggers, for example. So you can consider to use this approach, this second approach. And of course, Debezium also implements Xstream solution. However, a very expensive Oracle Golden Gate license is required. So perhaps it's not the best decision. And the next decision is some symmetric DS. It uses triggers to write changes to a service table. Then data packages are formed and transferred for the exchange between the source and target nodes. And of course, for SQL servers, there are also Debezium connectors. You can click the links and read the documentation. And if you have some Informatica licenses, you can use the Power Exchange CDC data source. In short, it also the Java application. It also use LogMiner to capture the changes and to transfer them to message queue. So let's talk about backup management and recovery. To do so, it's recommended to use the pgPro backup utility. It has been developing in the Postgres Professional and offers the following benefits, like incremental backup and restore, a backup validation and verification, multiple threads usage while making a backup or restoring from it, and backups from standby. For more information, please click the following link. And when Postgres monitoring is concerned, we recommend to use Mamonzo and Zabbix Agent 2. Mamonzo is a monitoring agent for collecting Postgres and system metrics and send them to the Zabbix server. Mamonzo has been developing in our company, and it works with various operating systems. One agent can collect metrics from one database instance. Mamonzo works with Postgres starting with the version 9.5, and it also provides various metrics related to Postgres activity. Zabbix agent, some of my colleagues have implemented some Exlogic, so our company has also participated in its developing. It's another tool for collecting various metrics, which is available from Zabbix version 5.0. One agent can collect more than 95 metrics from multiple Postgres instances. It's available from Zabbix standard repository. It can work with Postgres version 10 and higher. And also there is opportunity to write custom plugins by using Golang. As a company, we have participated in several system migration from Oracle to Postgres. Let me show you some brief systems descriptions. It's required to transfer a corporate document management system to the Postgres Pro standard. The total database size was 600 gigabytes, and the number of concurrent user sessions on the application servers was varied from 600 to 800. All business logic was implemented on the application sides. And what were the main goals? It was required to develop an automated procedure for transferring data to the PostgreSQL standard database, to find out the objects list to be transferred, to provide some solution for improving the database performance, and help the customer to convert heavy queries for work with the PostgreSQL standard. As a result, the following actions have been performed. Scripts for automatic invocation of the Oracle PG and Pentaho Kettle utilities have been designed for schema and data conversion. The user could specify a list of transferred objects as well as a number of simultaneously reading and writing threads by using the configuration files. Heavy queries have been converted and recommendations for the optimization have been developed. Schema changes have been included in the migration procedures in form of small patches, and consultations for the database management system and operating system tuning have been provided as well. We also have more complicated cases, and let's have a look at the example. It's required to transfer a corporate department system to the PostgreSQL enterprise database. The total size was 5 TB, and the number of concurrent user sessions on the application service was spread from 2,000 to 5,000. 95% of business logic was implemented on the application side, and 5% was implemented in the form of Oracle views for reporting. And there was a table with large binary data with a total size of 4.5 TB, and tables with a number of rows greater than 1 billion. And what were the main goals? They were similar. So we should develop a procedure. We should find out what objects should be transferred. We should convert views for work with the PostgreSQL enterprise, and to optimize the database itself to handle hundreds of user sessions on a server with many cores. And as a result, the following actions have been performed. So the scripts, of course, have been implemented by using Oracle PG and Pentaho Kettle. The user could specify a list of transferred objects and the number of simultaneously reading and writing threads. And the views have been optimized for work with the database, and the DBMS and the OS tuning have been provided as well. We also find out some ways to track changes in tables with binary data and a large number of rows. And of course, patches of the database management system kernel itself have been developed to optimize working with a large number of user sessions, to reduce the concurrency, to reduce the number of logs that were required to process with some internal shared data structures. Okay, and finally, let's have a quick look to Postgres features from version 12. The partition pruning mechanism has been improved, and now it allows to extract data from the necessary partitions, not only at the planning stage, but also during a query execution. In many cases, you can see never executed in some plan nodes, and it's very good because planner doesn't go here during its because Postgres doesn't go here during its execution. The partition by or divide and conquer mechanism has been improved, and now allowing to join the corresponding section with smaller size. B-tree indexes sizes have been reduced, as well as the database size as well, because in most cases the database size is the size of its indexes. Extended statistics can be used with various filter clauses as well as with the in operator. So the planner can produce more accurate plans. And of course, we can use multiple extended statistics in one query. For example, suppose we have a query where we have multiple filter clauses, and we have also group by clause, and all these clauses are related to one table. We can use MCV and distinct statistics to provide Postgres more information, and Postgres user can use it and choose a more accurate plan, and it's good. Also, we can process, Postgres can process multiple indexes concurrently while performing vacuum operation. We have an ability to control common table extension, common table expression behavior, like hint in Oracle, like materialize hint in Oracle, of course. PLSQL internals have been improved in terms of performance. Now it's not required for each and every statement, even if it doesn't relate it with the SQL itself, to be parsed, analyzed, planned, and so on. So there are a few context switches. And also there is an ability to create extended statistics based on the column expression. It's available from Postgres 14. There is no need to make changes in the schema, which is pretty good. And also you can, what you can do, you can use some parameter from Postgres, well, perhaps 13 maybe, yes, 13, and to analyze and to analyze and to come to tables, to append only tables and solve the problem with wraparound. And before that, it wasn't possible because after vacuum comes for tables which data were modified. I mean, update, and were affected by update and delete commands. And you can see the links, and it contains all the utilities and solutions we have already discussed. You can click the desired link and to read more and to find more detailed information. And this talk has been finished. If you have any questions, feel free to ask, and I'll do my best to answer them. Thank you. Well, let's have a look into the chat. Perhaps there are some questions. If not, I will be waiting for them. I would like to just mention that the real challenge is queries performance. So I can tell you that to convert it to the Postgres compatible syntax is pretty simple, and for me it requires only a few hours. But to make it work faster, for example, in Oracle, it may take you some days to understand what the Postgres planner expects from you and why in some cases it can't produce the plan you want. So what do we have here? Okay, for now I don't see any questions. So what else I can share with you? I highly recommend you to when it comes to data migration with minimum downtime, to suggest to be familiar with the Debezium, because it's a technology. Its solution is very powerful. Moreover, they have implemented the log miner solution previous year. They have worked for it for almost maybe 4 or 5 years, but they have managed to implement it. And as I have just said, some of our colleagues have tried to use that, and they said that it's working perfectly. They even managed to use the Debezium with the cloud solution, with some of the cloud solution, and they have reported that no problems have been encountered. Yeah, and again, if you want to if you want to make your life a little bit easier with your okay, there is a question. What is the effective scheme to migrate new partition of Oracle tables with change data capture? Okay, as far as I know, what can we do? We can check the data. We can check the data dictionary to see if new partition was created. And as far as I know, developers have implemented the DDL changes, so it should come to you in the form of some message to the Apache Kafka, but it should be checked. I have heard that they in some cases had some problems with the data definition language. But a workaround here is to use some data dictionary. Moreover, if we work with Apache Kafka, we can, for example, store some messages in the so-called intermediate data structure to create the partition, and then load the data to the target table. Okay. The second one, is there any alternative of Oracle query hints in Postgres? Yes, it's so-called PG hint plan. Thank you for the question, but I must warn you about one thing. Perhaps you are familiar with so-called parallel hint. Suppose that you have multiple common table expressions, and perhaps you want to speed up one of it. And therefore, you just write parallel. You can choose the number of processes you want, and after that, you will execute your query. In Postgres, there is one thing. As you know, this hint is controlled max parallel workers per gather. So you cannot activate it for a part of your query. You can activate for the whole query. So that's a pity. However, I haven't found anything else except PG hint plan, so you should consider using it. For example, you have stored procedures in Oracle when you're opening transaction and updating to tables in different schemas. In Postgres, you will have two separate databases and will update using FDV. Well, let me think. I understand your question, and let me explain to everyone. You see, in Oracle, user and schemas is this user and the schema is the same thing. For example, we have maybe, I don't know, SDO1 schema, SDO2, SDO3 schema. And the question is, should we create two separate databases to fill the data? To be honest, it's not required, because in Postgres, schemas and users are not the same. So you can create in one database a lot of schemas, and therefore you can open a transaction and just go to the desired tables and update them, insert, or whatever you want to do with them. But there can be another case why you would like to have it in a separate database. It's so-called maybe microservice approach. Suppose that you have a huge monolith system and you want to divide it into smaller pieces. Perhaps you're a fan of Spring microservice architecture, and therefore you desire to divide your system into small pieces, and each microservice will have its own database on a different service. You can consider this approach if this you want to achieve. But as far as I can understand your question, you just asked me if the user and the schema in Postgres are the same. No, they're different, and you can have a lot of schemas in one database. Therefore, it's not required to use foreign data wrapper. But if you would like, you can use, of course, foreign data wrapper and DB-Link extension. So does foreign data wrapper support transaction, or better to use to face a transaction in this scenario? Very interesting question. To be honest, I have heard that some developers do it on the application side, not PDV, by using two-phase transactions. So they have implemented this on the application side by the second approach, as you have mentioned. Okay, how can we migrate application from Oracle to Postgres if the application is packaged product? Well, it depends on what you mean by packaged product. For example, if it's if it is Oracle-based technology like Apex, yeah. You should implement a lot of things. First of all, your web interface. You cannot use the approach when you use the XML files to build and some JavaScript to build your web interface and packages to write your code. So you should re-implement it as well. Therefore, Apex is very hard to be re-implemented. It requires a lot of effort. But if you have a lot of packages, maybe what you want. Packages like a lot of packages. There are a lot of packages, and all the stored code are stored in packages. I can recommend you to use Antilayer v4 and see what can be done. Perhaps you have a lot of stored code, but it's simple. And I heard some examples that some company had a lot of stored procedures, but they were not so complex, and they use Antilayer v4 to create the converter. And by the way, if you're interested, all commercial converters are based on Antilayer v4. And but maybe you're speaking about the situation when you have some vendor code you cannot access and modify it. In this case, perhaps you should look for some adapter to emulate the behavior. I have heard rumors about that, but for me, I have worked with application and I could see the source code. Okay. Is there any good alternative of Pragma transactions in Postgres, for example, using in trigger for log data? You mean autonomous transaction, perhaps? Of course, you can. If you're speaking about autonomous transaction, you can use DB-Link. It's the first so-called old-school approach. You can use PG background to create background workers. They will connect to your instance and will have a separate transaction. Or if you're interested, we have implemented this functional as our database core. So it's available, and you can use Pragma inside your procedures definition. But if you're a fan of open source, I recommend you to use PG background. What is option for create library DB object in Postgres? How to handle this during migration? Well, creating library DB. Creating library statement. Perhaps you're speaking about that. I understand what you're meaning. Perhaps you're speaking about so-called stored procedures that have been created, that was created by using C programming language. Well, in this case, the only thing I can tell you, well, if you have a such solid level, you can write your own extension. You can write your own extension, because the main Postgres power is that there are many places that you can influence by creating your own extension. You can create your own library. I mean, to provide some functions. If you really have a solid level and you're a C programmer, you can just create your own library. You can just build it by using Postgres framework, and then you can use it. If you're interested, for example, I have mentioned PostGIS. PostGIS is a huge extension for Postgres, and they provide a lot of new additional data type. It's also, well, in some cases, library, because it can provide you additional functionality. But in other cases, for example, perhaps you want to convert some Java code. I have heard about PLJava, but to be honest, I have never used it. But when you ask about library, it's a shared object, and therefore I highly recommend you to write your own extension if you have solid level. Really, if you know C, you have everything you need to write your own extension. Okay, this is regarding normal trigger in Oracle written on view on update of some columns using when clause. How to handle this? Postgres doesn't support when clause for trigger writing on view. Well, as far as I know, there are so-called DDL triggers, and I can double check the documentation, but I believe that this feature is available in Postgres. It should be available, because we don't have only data manipulation language triggers. We have only DDL triggers.
So we don't see any other questions?
Yeah, there is so-called create event trigger. Perhaps it's the one you want. So what else? Oh, to be honest, I will go to the approach of the event trigger. Okay, I can see. Okay, I can see that there are some questions that I had missed. Let me double check it. How to deal with application which are using third-party plugins to connect to Oracle. It really depends what plugins do you have. Perhaps it's just JDBC drivers that you can replace. Perhaps this plugin are object relational mapping, and the only thing you need, and there are two things that you need is the first one to check what the plugin is, if it's object relational mapping, to do some tests and to make sure that it works perfectly. So what else? I have basic queries. Would you please provide more information as below mentioned queries? my globe data type field size are near 4 GB. How to migrate to Postgres? To migrate, so what can you do? If it's there is some documents, perhaps you can use some external file storage. There is an approach that you store the data outside the database and place on the metadata for it. Perhaps you're speaking about bfile. Alas, there's no transaction mechanisms inside this, so I'm sorry about that. But I don't think it's a good idea to place such fields, such documents inside the database. Okay, I have a range and interval partition on Oracle. Is there any alternative in Postgres? Range partition is available in Postgres, and what about interval? Well, maybe in the next version there will be an improvement, but the reason you asked the question is that in interval partitioning, as far as I remember, the new partition is created automatically. However, as far as I know, it's not the case in Postgres. So you should have some background jobs to see if it needs to be created. But maybe in further versions, the situation will improve. I understand that it's highly demanded feature. So, okay, my database size is 5 TB to 10 TB in Oracle. Which tools is the best for data migration to Postgres? For full migration, it's Pentaho Kettle, as I have just mentioned. If you have limited downtime, so try to use the Bezium with LogMiner. However, if you have so many data, it's a reason to understand what data are you storing. Perhaps you have some data for the analytic. Maybe you can divide your database on some parts, like in microservice architecture, but the answer to your question is try to use Pentaho Kettle and LogMiner. But I must warn you that you should be able to deal with some vacuum issues, so your tables will not be filled with with the old data. So what else maybe I have? Okay, which tool is the best for schema migration or conversion? If you are considered Oracle, it's Oracle PG. If you want to migrate from a SQL Server, you can use pgLoader. Okay, what else? Which are the major challenges for Oracle to Postgres migration? As I have just mentioned, it's the query speed, it's the planner, because from Postgres 12 you can use some advanced techniques. Coming from Oracle, for example, before working with Postgres, I used materialize and not materialize hint in Oracle to control the common table expression. And when I came to Postgres, I was a little bit disappointed to see that the only option was to materialize the common table expression. I couldn't push predicates to before Postgres 12, but starting from Postgres 12, I was able to do so. I was disappointed to see when I came to Postgres, it was 8.4 and then 9.5. There were no extended statistics. There was nothing I could do. But starting from Postgres 12, when they have normal statistics like MCV, then I can make the difference between a good query execution plan and the terrible query execution plan. Auto-PG also not converting code correctly for procedure using UTL file. As I have just mentioned, UTL file is, UTL file, as far as I know, or FSE extension should handle this. Yes, yes, it's available in Aura FSE. Try to use this. Aura to PG report assessment are not enough for database migration, also not support for all data or code migration. Of course, Aura to PG report is not sufficient to assess all your migration costs because of the queries, because you may end up that you can convert your query. However, it's difficult to make it work fast. I can give you one example that I had a query with 9 joins with partition tables, and I managed to reduce it more than twice. I ended up with only 4 joins. So, and you won't see it until you try to convert it and to run it. So, Aura2PG cannot predict it. Perhaps you have some data conversion, implicit data conversion issues, like convert from string to number. Of course, Aura2PG cannot protect you against that. And it's pretty nasty because this kind of mistakes somehow should be recognized and should be placed in the final assessment. Oh, okay. There are new question. Have you used Amazon Database Migration Accelerator for migrating Oracle to Postgres? No, I haven't used Amazon products. Moreover, I don't know if our company will place our database inside the Amazon. I know that we place our solution inside Microsoft Azure, but as far as Amazon is concerned, well, I don't know. Maybe we have some plans, but I haven't heard about it. Oh, the Oracle timestamp with milliseconds up to 9 digits. When we migrate to Postgres, the value truncate to 3 precision digits. How to migrate exact value in Postgres? Do you want to convert it on Windows? Because I have 3 precision digits in Windows. When Linux is concerned, I have 6 precision digits. And the question is, do you really need the all 9 digits? Because when I have worked as a PLSQL developer, 6 digits for me were more than enough. Well, I guess I guess I see all the questions and don't miss anything.
Okay, then thank you, Peter, for your talk and answers to all the questions. Thanks to everyone who attended our today's virtual event. Please expect another email from me with the links to the video and slides soon. You can also save the date for our next PostgreSQL event on clustering and high availability. It will take place on the 7th of October. So, thank you all again, and goodbye for now.